Hey fellow Python programmers, this is a part of the video that I never wanted to do, but nevertheless it has to be done, and you'll know why in just a bit. After 58 minutes of recording and having my throat very sore because I even mentioned that at the end of this video, I stopped recording. I pressed stop on all of my devices, and then as I was listening to the voice quality of this video, I realized that I was not using this microphone. I was using the microphone of my laptop, which is a huge disappointment because the microphone of my laptop is very, very bad. So I was thinking, should I re-record this? I have 58 minutes, so this is not a small video. It's 1 hour of 100% concentration, and it really takes a lot out of me. And I just want to let you know that this is not a standard for my videos. I pride myself. I've bought this expensive microphone. I've bought the expensive stand. Everything is really professional because I am an instructor, and I know that delivering a good information to the student is not just about the actual information that's inside, it's also about the method of delivery. The sound quality has to be perfect, in my opinion. But eventually I decided that I will just edit out the video, and I just found that the voice from this camera is acceptable. It's not very good, it's acceptable. It's very low, so you'll have to turn up the volume, but in any case, if you feel that it's really bad, I would love to know your opinion in the comments. If it's very bad, I'll have no other choice than just to re-record it. But honestly, at this point, I don't know, maybe you're watching this and my channel blew up, but I barely get 200, 300 views, so honestly, like, so much more work for barely anything, and I don't get paid. I do this for free. I have other sources of income, but YouTube is just something that I do for free, so I just thought, it's not worth re-recording. Now, if there is a big backlash about this, just let me know in the comments, and I will have no other choice than to re-record it, maybe somewhere down the line in the future. But I just feel devastated about this, and let me know what your opinion is. And without any further ado, let's jump into the bad sounding video. Sorry for this. Welcome back, my favorite Python programmers, to a brand new video, and in this one we're going to be creating a banking system using object-oriented programming as a Python exercise, and we'll be covering the following topics. So if at any point you feel that you're enjoying the contents of this video, please make sure to smash that like button because I need to beat any algorithm that's out there. And let's go ahead and get started. Okay, so as always, I'm going to be giving you the banking system program guide first, so you can try it out on your own, and then I'm going to be doing it myself. Again, as I told you before, you can see all the points, you can go test them out yourself. If you feel that you're stuck at any point, you can go watch what I did and then continue on from there. The most important thing is that you always try your best. So, first of all, you need to create a function that creates a random number between 10,000 and 99,000. It will be used to set the IDs of the account holders. So again, every account will have a random number. This is your first task. Next, you'll need to create a class bank account with a constructor that takes in the account holder's name, gives him a number, and initializes a balance. These are going to be the three attributes. So if you don't know how classes operate, I'm going to link the object-oriented video explanation somewhere around here, so you can go watch it before you continue on. But if you already know your way around object-oriented programming, then you should know how these work. This class should have a deposit, withdraw, and the display details method. For deposit, the amount should be positive, same when withdrawing, but also the holder should have enough in their account when they are withdrawing. So these are three simple operations for a bank. You can deposit, you can withdraw, and you can also display all the details about your account, like your name. You display all three attributes of a bank account. Next, you'll need to create a savings account that inherits from the bank account. The constructor takes in the account holder and the minimum balance and calls the super. Again, super, something that we've explained before when working with inheritance. It also has a withdraw that overrides so that the account balance never goes below minimum. So it also has a withdraw that overrides. So this is a withdraw method that overrides the withdraw from the initial bank account, and you have to make sure that now, instead of just making sure that you have enough, you need to make sure that you never go below the minimum, because remember, and a minimum balance. So a minimum balance is introduced into the savings account. Next, you'll need to create a class for the checking account that inherits from the bank account, and the constructor takes in the account holder, calls the super, and sets the checkbook issued to false. So a new attribute in here is added, that is the checkbook issued. So again, this is a checkings account. If you don't know the difference, a savings account usually is designed to save money in there over time. It gives you interest, and just we've added one extra attribute or one extra functionality to it where you have a minimum balance that you cannot go below. And a checkings account is usually intended for daily transactions, so you also get a checkbook with it. If a checkbook is issued, then it's set to true. If it's not, then it's set to false. And you should have should have its own method to set it to true. Only one checkbook can be issued per account. So this is something that you have to keep in mind and figure out. And finally, test out all of these classes and methods. Make sure that everything's working at every single step. So pause the video right now and go do the program. Okay, so as you can see, this is our first function. We have a simple function called the generate account number. This function doesn't take any parameters, meaning that you don't need to provide it with any information whenever you call it. Inside the function, we simply use a simple random.randint. Now we had to import the random right here at the top. Some of you, and including me, may not have done that, and what you simply did is typed in random, hit dot, and hit randint, and hit the tab, and the random was imported automatically. But I do recommend that you do this manually, because not all IDEs are like PyCharm and allow you to do such a thing. But anyway, after, of course, we have this small explanation right here of what this function does. So whenever we are using it, or whenever somebody wants to fetch the documentation for such a function, you can know exactly what it does and what it returns. So finally, we use the randint to get a random number between 10,000 and 99,999, making sure that every account in there is or has 5 digits. That's why we don't start at 1 or at 0, we start at 10,000. And the function then just returns that random number, and this allows us to generate a random ID for each account holder. I'm not going to test it right now. I'm going to instead do it in the class bank account. Okay, so in here we've defined a class that is the bank account. First, we have to initialize the method in it. This is a special method that is called whenever a new instance of a bank account is created. And again, if all of those words like constructor, init, instance don't make sense, you need to go and watch how object-oriented programming works. I'm not going to go into all the details. I'm just explaining these right now for our initial classes. So it initializes the instance with specific attributes, and those attributes are the ones that we provide, like the account holder, and the ones that will be set automatically, like the account number. Well, not automatically, we've done them manually right here in the code, but they get set with, for example, a function, and the balance is initialized to 0. So let's talk a little bit about these attributes. First of all, we have the account number, which is just the ID that each individual account holder will have, and it's a random number that is made up of 5 random digits from 10,000 to 99,900, etc. Now, something that's very important before we continue with the attributes is this self right here, and this refers to the instance of the bank account class on which the method is being called. So, for example, when I will create a new holder of a bank account, then that holder is going to be referenced with the self so that we know that we're setting the account number to that specific instance. And I'll show you and I'll tell you a little bit more about this, and I do go in depth into the self and how it works in the previous video. Nevertheless, let's continue on. And finally, we have the account holder attribute. So this is the attribute, this is the parameter that was sent. So the account holder that was sent is set to the attribute account holder. And finally, we have the balance attribute that is set or initialized to 0, indicating that the new bank account starts with a 0 balance. And of course, the self right here, if you double click on it, you can see that this self right here is the same self that is sent. Okay, so in here I've created two methods. I wanted to create the third one, but I felt that I've been typing code for too long and it's time for a bit of an explanation. So first of all, we have the deposit, and second of all, we have the withdrawal. Let's go through them one by one. So inside of this bank account, we've added some functionalities. First of all, we have the deposit method that allows us to add funds to the account. First thing it does is it checks the amount specified or sent to it through this parameter right here, and it makes sure that it's greater than 0 because only positive values can be deposited. If the condition is met, the method adds the amount to the self.balance and prints out a confirmation message along with the new balance. But if the amount of the deposit is not positive, then a warning sign is printed out that only positive amounts can be deposited. Next, we have the withdrawal method, and it's similar to the deposit, but for removing funds from the account. First of all, it checks if the amount is greater than 0 and does not exceed the available balance. Keep in mind that it can be equal to the balance, which means that you can take your entire account to 0, but you have to have strictly more than 0. This is something that I noticed as I was writing the code, and it makes sense because if you try to withdraw 0 and you already have 0, that shouldn't count. You should have at least 1, which is strictly greater than 0, and then you can withdraw some money from your account. So if the conditions are met, again, the amount is subtracted from the self.balance. So we are something that might have slipped as I was explaining. In here, we're accessing our own balance. So we say self.balance. Remember, this deposit is going to be called on one of our instances of the bank account. So how do we know that we want this specific instance to be changed? We use the self parameter that's being sent, and then we use the self.balance and add the amount or subtract the amount right here. And finally, we have this printout statement just telling us how much we withdrew and our new balance. And if these conditions or one of these conditions is not met, we print out insufficient balance or invalid withdrawal amount. Now, I'm going to test all of these out, but first I want to finish the last method and then we will start creating instances. Okay, so this was the last method, which is just to display all the details. Nothing too complicated in here. I simply have a printout statement. So this function, this method, when called, simply prints something out and does not return anything. Similar to the deposit and withdraw, by the way, they simply print things out and modify the attributes. This one, on the other hand, does not modify any of the attributes. It simply accesses the account number of the self, accesses the account holder of the self, and accesses the balance of the self, which is the instance. So now let's go ahead and test these out. Okay, so as you can see in here, I created bank account 1, bank account 2, and then I displayed some information after I've made some deposits for and withdrawals for both bank accounts. So again, what is happening in here? Bank account 1 is created. This is the instance that we're trying to create, and it's of type bank account. I say type because this is the class, and look at this. If I hover over the bank account, you can see that it looks as if it's a method or a function that's being called that takes in the self and the account holder. So now bank account 1, when we say bank account 1 dot deposit, when we say bank account 1 dot deposit 100, this self right here is going to be the bank account 1, so that when we deposit, only the balance of bank account 1 is changed, not that of bank account 2 or bank account 3, it's that of the bank account 1. This is why the self is so important, and this is the whole point of using object-oriented programming. Anyways, I've deposited 100, deposited another 100, we should have 200, then withdrew 50. And I did the same right here, but I also tried to deposit minus 30 just to make sure that we can withdraw. I'm also going to try and withdraw in here again and try to withdraw maybe like 780 just to see and make sure that the withdrawal works. So right click and run, and boom, deposited 100, deposited 100, new balance is 200, withdrew 50, now the balance is 150. Right here you can see everything displayed properly, and we have random numbers. If you right click and you run again, you can see that these change because these are indeed random. So for Kalen, we deposited 50, deposit amount must be positive, so this is when we try to withdraw minus 30. Then we withdrew 10, we have 490, and we have insufficient balance or invalid withdrawal amount because we tried to withdraw 780 while we have 490. And you can see this is the balance, and I can see that there's something wrong in here. The balance, I probably should add a space right here to make the output, look better. So the only problem was that Michael was stuck to the balance, and that is because right here I did not have a space. And in any case, I think even better than a space, we should also add a comma. And if you feel that this line is getting too long, simply hit enter. The placement, or because these are separated into different lines, should not be reflected in the output. Or actually, it will not be reflected in the output. As you can see, they are on the same line. If you do want them on separate lines, you can start adding \n, which are escape characters. Boom, there we go. You can see these are on new lines, but I don't like it like that. There we go. Everything is working good. Now, let's go ahead and create some savings account. Before I go, I want to remove these. These are just for testing because we're not going to be creating bank accounts instances. We're going to be creating savings account and checkings account instances. So these were just for testing, making sure that everything works. I don't like to delete them, so I'm simply going to hit Ctrl//. This will comment out everything. If you're on PyCharm, if you're on a different IDE, the shortcut might be different. Okay, so in this code right here, we've created a new class that is the saving account or savings account, which is a subclass, or it inherits from a already defined class that is the bank account class. This subclass represents a specific type of bank account with some additional rules and some additional attributes. So let's look deeper into it. First of all, we have the init right here. This is the init method that we've already seen, and again, it's called whenever a new instance of the savings account is created, and it takes in the account holder just like the bank account did, and now it also takes in the minimum balance as a requirement. Now inside of this init method, we have something called the super.init account holder, and this basically what it does is it calls the parents class, which is the bank account's constructor, to initialize the common attributes like the account number, account holder, and the balance. So whenever I say super dot inside of a class that inherits, or inside of a subclass to be more specific, the whatever comes next is the function, or the method or the constructor or whatever it is, usually it's the method, of the parent class that is the bank account that is called. So in here, when I say super.init and I send in the account holder, oh, there we go, perfect. So you can see when I double click on it, the init of the bank account is highlighted because it's the same one. It's not this one. Notice that this one is not highlighted. If I double click on it, this one is not highlighted because this init is different than this init. This one, this constructor, is for the bank account. Notice how it's highlighted. So whenever I say super.init and I send in the account holder, it's as if I'm creating an instance of the bank account, but because it's in the init of the savings account, then it's an instance of the savings account. And notice that because it inherits from the bank account, it's going to have its own account number, its own account holder, and its own balance, in addition to the new attribute that we add after calling the super, that is the minimum balance. So this is a new attribute that is unique to the savings account that defines the minimum allowed balance, or the minimum balance that must be maintained in that account. Now, if we go back to the top, you'll see that we have a few new circles that appear right here on the left-hand side. And if we hover over one of them, you can see that is subclassed by account or savings account. So this is subclassed, meaning that it now has a subclass that is the savings account. And you can see right here, if we hover over next to the init, is overridden in the savings account. And next to the withdrawal, we also have is overridden in the savings account. So whenever I scroll down, you can see for some reason the init doesn't show it, maybe because it's not really overriding. I don't know if it's not overriding. It does indeed call the init from inside. I don't know the exact nomenclature that it needs. I don't even know if nomenclature, it's French, nomenclature. But anyways, you can see that the withdrawal, if we hover over it, overrides the method in the bank account. So let's look at the withdrawal and what makes it unique. It's similar to the previous withdrawal, but now we have an extra condition because before we are able to withdraw, we need to check if the self.balance, once the amount that we're trying to remove is removed, still is greater than the minimum balance. If it's less than the minimum balance, that we print out that we cannot withdraw because a certain requirement is not met, which is the minimum balance requirement. So basically what we do is we get our balance, we remove the amount, and then we check if it's still greater than the minimum balance. If it is, then we do super.withdraw. And what is this withdraw? If I double click on it, you can see that it's the withdraw that is in the bank account class. So very important. This withdrawal right here is different than this one. So withdraw is called. Now, why is this called an override? Because now when I have a savings account instance and I call the withdrawal, this one will be called, right? Not this one, not the one in the bank account, the one in the savings account. So this is a subclassing approach that allows the savings account to inherit the general behavior of the bank account from the bank account class while also enforcing additional rules. And this is a very good example of inheritance where you have custom functionality and some extra attributes. Let's go ahead and continue on by creating the checkings account. Okay, so as you can see in here, we created a new checking account class, and this is another subclass of the bank account, which is again tailored to be akin to a checking account. And keep in mind, this is not a professional class. This is not a professional program. Of course, there would be much more differences between a checking and a savings account, but for the purposes of this practice exercise, these are how we have them. Anyways, let's look deeper into what we have. Again, we initialize the init method that takes in the account holder and doesn't take any extra attributes to be set. Again, in here what we do is we call the super init. So we call the init of the bank account and we send it the account holder, and we add an extra attribute that is the checkbook issued, and we set it to, or initialize it to, false. This means that every single checkings account is going to get a checkbook, and one of the rules that I told you about in the guide is that every account should only have a single checkbook issued for them. That's why we have the checkbook issued because later on we create a method in here that issues a checkbook for every single checkings account. This method manages the issuance of a checkbook for the checking account. First of all, it checks the state of the checkbook issued to determine whether a checkbook has already been issued, if not issued. So whenever we have a not, what we do is whatever we have in here, whether true or false, is converted to the opposite. So for example, if self.checkbook issued is equal to false, not is equal to true, which whenever we add the not to it, which means this entire statement would be true. That means we go into the if statement and we set the self.checkbook issued to true, and we say that the checkbook is issued. But if it's already true, so if this one is true, not true becomes false, and we don't go into this one, we go to the else and we say that the checkbook has already been issued. So now that we have these two classes created with their respective method, let's go ahead and test it out. Okay, so as you can see, we created two instances. First of all, we start by creating a savings account instance for Frodo Baggins with a minimum balance requirement of 500. Then we deposit 1000 into Frodo's savings account, which means that we should increase it by 1000, and next we attempt to withdraw 600. And this transaction should be unsuccessful because the withdrawal of 600 leaves us with 400, which is less than 500, which is the minimum of the savings account. So then we separate with a 50 and we create a new checkings account instance, which is Voldy's checking. This is the variable name. I don't make these up. Then we have the name of the holder, or the accounts holder name, Lord Voldemort. We deposit 2000. We issue him a checkbook. We withdraw 1500, which should not be a problem because there's no minimum amount that should be kept. And we finally display the details. Now, something to keep in mind in here, notice that we were able to deposit to both these accounts and withdraw, and display to these two accounts, even though, for example, savings does not have the display details, neither does the checking account. And by the way, the checking account doesn't even have the withdrawal, and this is the power of using object-oriented programming. You can now create savings account and checking account which inherit from the bank account and use methods that were created in said bank account, like the display details. So instead of me having to copy this and print it in the savings account and then print it again in the checkings account, I can simply create it in the base class, that is the bank account, and then use it on all subclasses thereafter. So let's right click and run and see if everything works. So first of all, we deposited 1000, cannot withdraw, minimum balance required not met, and then the account number is 28,757. Account holder is Frodo Baggins with a balance of 1000. Excellent. Next, we deposited 2000, issued a checkbook, withdrew 1500, and Lord Voldemort has 500 left in their balance. One more thing I wanted to do, I want to duplicate this line by holding Ctrl D and just put it at the bottom, right click and run, and it shouldn't allow us. There we go, checkbook has already been issued. So everything works fine. Okay, fellow Python programmers, congratulations on making it this far. Oh, we've covered a lot. Well, not a lot, but we've created a very nifty function that gives us a random number. We've created the class bank account, which sets up everything or all the other subsequent subclasses and sets up the methods like deposit, withdraw, and the display details. We've also created two subclasses, one the savings and one the checkings account, and we tested them out on our favorite fantasy characters, Frodo Baggins and Lord Voldemort. Anyways, now it's time for a bit of a challenge where you have to test out a new concept in object-oriented programming. Well, it's not new because you've already watched my previous video on object-oriented programming, but a new one in here that is the composition. And it's a different way of interacting or interaction between two classes. Anyways, I'm getting lost in my words. Let's delve into the challenge. Okay, so it's time for you to create some transactions. First of all, you'll need to import datetime class from the datetime module. this is something that we have never covered before, so I do recommend that you Google it. Next, you'll need to create a class transaction with a constructor that takes in the amount and the transaction type, which should be string, and the constructor then sets three attributes: the date, which should be datetime.now, the amount, and the transaction type. Next, you'll need to override the underscore underscore str underscore underscore method and return a different output. Very interesting. What is this underscore underscore str? I do recommend that you go and search for it. Next, you'll need to initialize an empty list of transactions whenever a new bank account is created. So now you are going to be modifying our classes. This is a big hint in here. You should have figured it out on your own. But again, initialize a new list whenever of transactions whenever a new bank account is created. You'll need to append this list whenever a deposit and a withdrawal is made, or a withdrawal is made should have been more appropriate. So you need to append this list of transactions, and remember, what do you send to this transaction? The amount and the transaction type. Add a new method in the bank account that prints out all of these transactions. So a method in the bank account in the base class should allow any holder of this account or savings, whether it's savings or checkings, should be able to see all of the transactions that they've ever made. And finally, make some transactions and test it out. So by test it out, I mean you need to print out all of the transactions that were made after you've made some. So pause the video right now and go do the challenge. Okay, so first of all, what we did is we imported the datetime from the datetime module. So basically, we're importing the class datetime from the datetime module in the Python standard library. This is something that is very typical whenever it comes to creating something that needs a certain time aspect to it. Like, for example, in our case, where we need to know at what time these certain transactions took place. So this is how you do it. I've never covered this before, so I didn't mention any video, but you should be able to do research on your own and find out how these things work. Now, this datetime module provides classes for manipulating dates and times. So, for example, this one in particular represents a specific date and time with year, month, day, hour, minute, second, and even microseconds components that will allow us to use these certain components right here to set a certain date at which specific transactions took place. Speaking of transactions, next we define a class called the transaction with the following components. First of all, we have the init to initialize a new instance of the class. Inside, we set an attribute date that will store the current date and time. And later on, you'll see I kept it like this, but later on, I'm going to add to it a special function that will allow us to change how it looks, because you'll see now it's kind of funky whenever you do it. And next we set a new attribute that is the amount. This is the amount, or this stores the amount of the transaction that was made. And finally, we have the transaction type that will store the type of transaction which was made, which should be either withdrawal or deposit. Next, we have the underscore underscore, which is another special method in Python classes that defines how an instance of the class should be represented as a string. And do you remember I told you that you need to override the underscore underscore str? And notice when we did create the underscore underscore str, we actually overrode, is that even right here, overrides method in object. Now, why does it override? It's because every single class that you create always inherits from a object class. So if I do this, for example, now it inherits from object. All classes inherit from object, but we don't have to write it every single time. If you don't believe me, you can hold down on Control. This turns into a link, and when you click on it, okay, so it's in here. Maybe if I click right here, excuse me. So you can see define str. This has already been defined, and it's in the class object. So every single class that you ever create in Python always inherits from object, even though we don't have to write it because it's special. So inside of the underscore and underscore str, we define how this whenever, or we define how, when an instance is printed out, how it should be formatted, and I will show you how that would look like. So let's now continue on and let's append or change our different classes to make room for transactions. Okay, so in here we've added a new attribute to the init constructor, that is the self.transactions, and this attribute is going to be an empty list that will be used later on to store the transaction history for every single bank account. So when a new bank account is created, an empty list is initialized to store all future transactions. And we do it right here, not in the init of the savings account, neither in the init of the checkings account. Why? Because this is going to be available to all bank account holders, whether it's checking, whether it's savings. So it's better to create it right here, so it trickles down into all other subclasses. And see how much more convenient this is. We had to create transactions list for both functions or for both classes if we did not have inheritance. So that is the power of object-oriented programming. Okay, so in here, after we've made a successful deposit inside of the deposit method in the bank account class, we then create, or we append our transactions, and notice we did self.transactions referring only to the transactions of the current instance of bank account, and we append it with a new object that we create that is of type transaction, and we send in the amount and the deposit, which is of course the type, and this is the amount that was actually deposited. Okay, and finally in here we have after we have a successful withdrawal, a new transaction object is created with the amount, and this time the transaction type is going to be withdrawal. This transaction is then appended to the transactions list using the .append method, and it's very similar to what we've done in the deposit. And also very interesting, we don't need to fix the withdrawal in the savings account class because of the power of object-oriented programming. Because in the savings account, when we make a withdrawal and it turns out to be good, we call this super withdrawal of, which means the super dot withdrawal is going to be the withdrawal of the bank account. So we only need to fix this or append the transaction list only right here. Okay, so in here we define a method called the print transaction history within the bank account class. And this method is going to, well, print out all the transactions history. First of all, we start off by printing out a header message telling us that, hey, look, this is going to be the transactions history. And then inside we create a for loop that iterates over all these self.transactions, because remember, this is a list, so we iterate over every single one. We set them in the temporary variable transaction, and then we print out the transaction. Now, what does this do? Because keep in mind, this is a list of objects of type transaction. Well, this transaction right here, when we print it out like this raw, this actually calls the __ str method. Where is it? The __ str method that we created right here in the transaction class, which then allows us to print out a formatted specific string. And I'm going to show you the difference between an object that's printed out using this __ str and an object that did not use it previously. So if we scroll down right here to the bottom, I'm going to add another print, and I'm going to add 50. And why am I saying I should be fast forwarding this? Okay, so as you can see in here, we created Harry Potter, their new bank account, with the account holder being Harry Potter. Now, I do recommend, if you want to test, if you want to go deep into testing, that you actually make this a savings or a checking books account to make sure that the transactions do append properly. Which, you know what, I do feel that it would be more appropriate, and then we'll just set this to 20 because we don't want to have any errors. We already know that the withdrawal works good, so no need to test that, but we do need to test and make sure that the transactions are recorded even if this is a savings account. But even though we already know the principle and it's correct, just, you always have to test out these things. Anyway, we deposit 100, we deposit 50, we will withdraw 75, we print out the details, and we print out all of the transactions. So when I right click and I run, boom, as you can see right here, deposited 100, deposited 50, withdrew 75, and the account number is 27,176. The account holder is Harry Potter, and the balance is 75. And look at that, the deposits were made in 2024 4/15, which is the date, and now it's 3/29/10, 0.81015, which is not a good number, and I'll show you how we can print it out in a better way. But anyways, you can see that we made a deposit of 100, a deposit of 50, and a withdrawal of 75. How cool is that? Come on. These are all of the transactions that we've made, and they're very, very good. Now, before we leave, or before I leave you, I just want to save or change how this is formatted. So all that we need to do is, if we go back to where we have transactions, so where we set the date dot now, okay, so now we simply change the way that this is formatted. We have all of the information, and we extract it using this modulo sign or percentage sign, you want to call it whatever you want. The big Y stands for the year, the small m for the month, and the small d for the date. For the day, and then the big H is for hours, minutes, and seconds. So now when I right click and I run, you should see that we no longer have this extra point something something whatever. Now the downside is we don't have the milliseconds, which was kind of cool because now it looks like all the withdrawal and deposits were made in the same or at the same time, which is not very cool. With the milliseconds, you were able to see what was happening. So actually, let me, you know what, I feel like this one looks kind of better. I mean, just for us, because we're doing this every single millisecond, you can see the difference. No difference at all. All right, so this was much better. Now later on, of course, this will be more prominent when the deposits and transactions are done at different times. Whoa, oh my god, ladies and gentlemen, I can barely speak. As you can see, my throat is sore. I've been talking straight for 58 minutes, and now we are done. In the next video, this time I do know what we have. In the next video, we're going to be looking at a library system, if I'm not mistaken, still using object-oriented programming, because object-oriented programming is a great tool and it really opens up a lot of possibilities for projects which we wouldn't have otherwise. So if you actually need to continue your Python learning journey by watching the next video, which is a library system. So click right here. Wait, I'm going to move this so you have space to click right here. Let's go. Continue your Python programming journey. I'm gonna go